Hi and welcome to the 7th video in the rates and equilibrium topic. This video is going to focus on the Haber process and what that is. So the Haber process is an industrial process used to produce ammonia from a reversible reaction between nitrogen and hydrogen, like I've shown here in the equation. So the Haber process happens under some carefully chosen conditions, okay? And those conditions are 200 atmospheres of pressure. So we have to put it under high pressure. We're using gases, so high pressure will increase the rate. 450 degrees Celsius in temperature, excuse me, and an iron catalyst. Okay, so all three of those conditions have to happen in order for us to have the Haber process and produce ammonia. These were chosen to give us the best yield we can for as little cost as we can. When we're talking about this, we need to know where our nitrogen and hydrogen come from. So our nitrogen gas is taken from the air. So remember, the air is 80% nitrogen. So there's lots of nitrogen in the air. We take it from the air and purify it so that there's just nitrogen there. We get our hydrogen from methane, which is taken from natural gas. Now we've got a problem with this because natural gas is a finite resource. And so eventually this will run out, which is going to increase the cost of this process as hydrogen does that, comes from that. And we react it with oxygen to create the hydrogen gas and then use it that way. So what does the Haber process look like? This is the Haber process. So what we have is we have a set of pumps. We have a compressor. We have a reaction vessel. And then we have a cooling chamber or a condenser, depending on who you're talking to. And here's what happens. So in step one, our hydrogen and nitrogen gas right here are pumped into the system, and they go into the system and into our compressor. And when they're in the compressor, the nitrogen and hydrogen is compressed to our 200 atmospheres of pressure and heated up to 450 degrees. Once they're at that correct temperature and pressure, they're then pumped through into our reaction vessel. And as you can see, there are like layers here in the reaction vessel. Each of these layers is our iron catalyst. And so as they fall through the reaction vessel, they will lay on and touch the iron catalyst, and then they will react. Now remember, this is a reversible reaction, so not all of the reactants will react. And what happens then is the reaction mixture is moved out of our vessel and into our condenser. And what happens here is that they are cooled. And I'm going to add a little bit of detail to this because they are cooled to the temperature that ammonia will condense at. So our two gases, nitrogen and hydrogen, will remain a gas. We're going to write that here. H2 and N2 will remain gases. And so what happens there is the ammonia comes out and we drain it off and we use it, and the unreacted nitrogen and hydrogen are sent back round to do it all again. And so it's a process where that happens. So any unreacted nitrogen and hydrogen are sent back to the compressor to go in again. We say that the unreacted N2 and H2 are recycled back into the system. And they keep going round and reacting and reacting. Now remember, the reversible reaction that is used will reach equilibrium. And this is the reason the H2 and N2 are recycled, because they're still there, because they will still be in that reaction mixture. Okay, guys, that's everything I wanted you to get for the Haber process today. I will be back again with another video on this topic soon.